So we are discussing about combined stress, right? Or more circle. So if a body has multiple stress in different direction, then what will be the resultant effect? That's we are working on it. In the last class, we stop it right over here. That say a body has load or force, external load from multiple direction. If you take a cross section, and that in that section, how many force or stress will be there? There will be one stress that is called normal stress perpendicular to the body. Say we cut it right over here. This is the cross section. So there will be one stress work directly along x-axis, and that will be sigma x. And there will be one shear stress that will work along this direction. So this component, if we divide into two components, one component will be along z-axis, other component will be along y-axis, shear stress. Now this shear stress, how we identify, I keep the notation. So shear stress we express by tau. This one is tau. Then this tau coming due to the sigma x, so I'll put x over here, I'll put x over here. This is working along z-axis, I'll put z. This is working along y-axis, I'll put sigma x, okay? So for one plane, there is three force. Three stress. Similarly, if you cut right over here, then your normal stress will be along y direction. Then you will get sigma y into tau y comma tau y. Now, along y direction, working sigma, so it will be y. And remaining what axis? X and z axis. So one will be z, other one will be x. Similarly, you can cut it along z axis. That means I have this mouse. How many direction you can cut? You can cut this way, right? So perpendicular will be x-axis after you cutting this one cut. Other cut I can slice horizontally. So sigma y will be what? Vertical. Other one I can cut it longitudinal direction. Along this direction will be sigma z. So if you cut in longitudinal direction, then there will be sigma z, tau z, tau z. So what is the other two x, xy? So one will be x over here will be z. So what did you see or what did you learn? That if you cut a body in different plane, there will be three stress, one normal stress, two shear stress. Now we have option to cut the body in three plane, right? Like YZ, XY, and XZ plane. So each plane has three force. So we have three plane, we have total 9 force. That means total 9 force is working through a point. For example, this Q, point Q. You can look point Q if you divide the point Q along this direction. If you chop it, cut it like that, okay? This is one option. Other option, you can cut this, chop it this, say potato, along horizontal axis. then how will be your shape? Your shape will be like that, and then will be bottom part, right? So this perpendicular direction, you will have sigma y. This is one option. Other option, that throw right over here, uh, on this way, or longitudinally. So if you cut it longitudinally with a knife, then this surface will be along z-axis. Okay, that means they at a single point eh, through a body, their night stress might work. So if a body is subject to multiple force, and you see a point P internal point on the body, inside the body, then how many force or stress he can experience? So he can experience total 9 stress. How? If you cut like this way from the vertical side, you put a knife, then you will get sigma x. You get sigma x, then you will get tau x z, then you will get tau x y. This is one. Other one, if I chop it horizontally through that point, then my vertical direction, my stress will be sigma y. Yeah, over here will be yz, then tau yx. So you see over here 3 stress. How come 3 stress? Cut like that and cut horizontally. Other, I can cut it longitudinally. So there will be shape that normal stress will work along z-axis. So we'll have one more sigma z tau zx comma tau zy. So you see total 9 stress work in a single point. Not single point. Whatever point you consider, throw a point, always there will work 9 stress. Okay. That you need to remember. Now you see there is a 9 stress, tau xy, tau yz. So you are getting a little bit confused, right?
Yes,
We
sir.
think, okay, yeah, tell me, go ahead. Any question? No
No,
question?
sir. No, sir.
No, okay. So like in fluid mechanics, we consider fluid element, rectangular shape, cylindrical shape, right? So inside a metal, if I consider a cube, very small dimension, say this is the cube, and this length dx, dy, dz, that means they are very small size. In that case, in this phase, what will be the stress? In vertical phase. So in this vertical phase, you see along, that means you cut it vertically. So along x-axis, there will be sigma x. So if I write down sigma x working along x-axis into, there will be two stress along y-axis, along z-axis, shear stress. That will be tau xy into tau xz. Okay. So this is a cube, right? I think this is a cube. So how much force will work, right, in this phase? Because if I try to make a line, this phase will be like that, right? So this phase, how much will be stress? So obviously this phase there will be sigma x. And this tau xy working upward, over here tau xy will be downward. And tau xz working along this direction, over here will be opposite direction. Because for equilibrium condition, and you take summation of the all force will be 0. Sigma x minus sigma x, 0. Tau xy working upward, this tau xy downward will be 0. Tau xz working along this side and this one going along this side, so this will be 0. So this phase has 3 stress, over here also has 3 stress, but they are equal and opposite sign. Similarly, in the top surface working sigma y. Then in this phase, there will be, we have sigma y. What will be the other one? Tau, tau yx. Other one will be tau yz. That will write over here. Tau yx and tau yz. Okay. Similarly, if I consider in this phase, along this direction, there is sigma z. So along other two directions, you'll see tau xz, tau zy. So how did you see? These are showing 3 phase, this phase, this phase, this phase. Actually, it has 6 phase. So some force working right over here, also in the bottom, also the back side, but they are equal and opposite. So always this, total how many stages over here? 9 stages. This 9 stages always work inside every point of the body. Now, this subscription they use, how they use, like this one, sigma z. Then for sigma z, there will be tau z, tau z. Except you already sigma z working along z axis. What is the other two axes? X and y. So you put over here x, over here y, comma. Easily you can figure out. So now you see through a single point there are 9 stress working. Now, what are those 9 stress? Right over here, sigma x, y, z, tau xy, all these 9 stress. Now, the body is not moving. We are working with a static body, right? So for that's why this tau xy working upward. So what will be this side? This tau xy will work downward. Tau xz working this direction, and this phase it will work along this direction, and sigma x will work along this direction. So this body is, there is no moment, right? So these two, this one and this one, I'm talking about this force and this force, try to rotate the body clockwise, right? Because he's pushing this direction this way. That means they are trying to rotate the body clockwise. Similarly, if you look this one, what will the back side? So back side, that means this side, this xz will be along this direction, and this yz will work downward. So in that case, this xz and this one try to rotate anti-clockwise, and they will be balance each other. For that reason, we can say that tau xy equal to tau yx, xz equal to zx, zy equal to tau yz. That's why we have 9 stress. From this 9 stress, we have only 6 stress. What is the sixth stress? We have sigma x, sigma y. Three normal stress along three direction. Into the comma, we have three other stress. Number one, xy. Number two, yz, and tau xz or zx. So 1, 2, 3, and 3 shear stresses. So total we have 6 stress. From 9, it was beginning at the 9. From 9, we got 6, right? Now, what is the definition of plane stress? Plane stress definition, there will be no stress along z-axis, other two axes. If I consider this is a plane stress, then along z-axis, all the stress has to be 0. So along this 6 stress, we can say the sigma z will be 0. There will be no sigma z, there will be no yz, no zx. So how many stress you got then? Sigma x, sigma y, and tau xy. So you get only 3, sigma x, sigma y, and tau xy. Okay. So this body right over here, no stress along z direction. That means this is come 0, this is 0, this is 0. Then how many stress you have? If you squeeze, make it flat, because along z direction there is no stress. Now in the upper surface, if I take the front view, upper surface there is sigma y, I put like that. And along and this will be 0, tau yz will be 0, tau zx is 0. At the top surface only you have tau xy. Okay. Similarly, in the right side we have sigma x, this value going 0, and we have tau xy. So if I draw a cube right over here, then we will have vertical direction sigma y. Then we have along this direction tau yx. So what will be in the bottom? I like to balance this one. So in the bottom there will be sigma y downward, and opposite of this one will be this one. So let me write down these 3 stress. So this is sigma y. Sigma y, and this will be sigma y. And this one is tau xy. This one will be tau xy. Now what happened? This force will be cancelled out. Summation of tau xy will be cancelled out. But if you take moment, tau xy, try to rotate this body along clockwise direction, right? They try to rotate the body along this direction. So let's see what's going on. If you take the other stress, like that over here, we have sigma x. So in this direction, we have sigma x. And this one is 0, right? This will become 0. We have tau xy upward. So we can say this one. Tau xy working upward. What will be the left side? Obviously, there will be sigma x left side. and this is working upward. So this will be downward, and its value will be tau xy. So you see, if you take summation of force along x-axis, then what will you get? Sigma x positive, right? Minus sigma x 0. Tau xy working right side positive. Along this direction, tau xy minus 0. Then you look this tau xy and this tau xy. Try to rotate the body clockwise. And the tau xy with the blue sign, they try to rotate body anti-clockwise. But their magnitude is same. That means body is a static equilibrium position. It is not moving. Okay. Now, inside a body, we'll think there is always three stress work. If you think that this is a plane stress formula, or it maintain the plane stress, so this three stress will work through a point. That we need to remember. Now, say for example, if I draw a pressure vessel, cylindrical shape, this kind of shape. Okay, I'll do this chunk of material. What will work right over here along this direction and along this direction? Obviously, sigma t, tangential stress. So right over here, we will have sigma t, right over here, sigma t. Seems like it is balanced, right? Now, along longitudinal direction, what will be stays right over here? It depends on sigma L. So along this direction, sigma L, along this direction, there will be sigma L. So let me write down, this is sigma L. Still, it is balanced. Now that I told you, during transportation, there might be torsional shear stress. Then what will be happen? Torsional shear stress will be tau along this direction, right over here, along this direction. Now this system is rotating. To keep it balanced, there will be along this direction, along this direction. So this figure now matching with this one, similar. So a pressure vessel, a cylinder or submarine, it don't get burst immediately. It take a while. While mean it might be 1 day, might be 10 minutes, or might be 5 minutes, or might be 6 months. Depends on what is the object, how much the pressure, how actually crack developed. Say you make some pressure vessel by foundry, okay? So there might be some impurity or some air bubble inside the material. So there might be some gap, or I can say some crack inside the material. And you don't know from outside, right? And how much the gap might be 0.0001 micrometer. That is not possible to observe in blank eye, on eye. Okay. So how material fail? Say this is material, there is a microcrack. So over the time, this crack gradually grow bigger. So it gradually go bigger. That means material gradually go weaker. and ultimately it get more bigger, then it get cracked. Okay, so you need to figure out that initial crack length, say this much, size was 2 micron, or might be less than that micron, might be, I'm saying, 0.4 micron, and that 4 micron gradually go bigger, and finally it become 10 centimeter. Then it will burst pressure vessel. Now, mathematically, you need to calculate that how long take time to grow this crack from 0.4 micrometer to 10 centimeter. Mathematically, you can figure out that how much load is there, how many forces there, what are the material. Then by plane stress formula or by plane strain formula, we can figure out the time. For example, I think the Apollo mission, I think I forgot the real name, but you can check with NASA website. There was a crash of the space shuttle while returning. Okay, and what they found when at the in the launch it, vehicle is going upward, and they put multiple camera inside, outside, and they figure out that in the space shuttle there is an engine at the backside, and there is a kind of tiles, insulation, heating insulation, and they say these tiles is get off from the surface, hitting this surface, and that crack, minor crack. So it go re-entry, go in the space close to the International Space Station. Then they calculate the is okay. If there is a crack, it will go gradually bigger, but still it can come back to the earth. They calculate it. Okay, so that's why they don't repair, but they can repair in the space station. Okay, so in the re-entry to the earth, then it got breakdown from here, and it is crashed. All astronaut died. Okay, so what I'm saying, this is very important. So right over here, what you see that in the plane stress formula, a pressure vessel might have this kind of stress. Now, what you see over here, a paper or a thin plate, somebody pulling like this direction, somebody pulling along this direction, then somebody pushing at the side along this direction, somebody pushing along this. What does it mean? That might be a twisting motion, but that motion is protected by someone pushing along this direction, someone pushing along this direction. That means they try to rotate the body anti-clockwise, and these two share stress, this one and this one try to body rotate clockwise, and this one try to rotate body anti-clockwise, clockwise, and this one anti-clockwise, like this way. So their magnitude is same and equal, so it become neutral. Now, how a material fade? Inside right over here, there might be a crack. So applied load, it gradually go bigger, then finally fail. For example, you take a piece of bread, rectangular size, right? You pull along this direction, you see gradually it is tear off, become two part, right? But same bread, I give you a steel plate made of steel plate or cast iron plate, then you pull it along this direction or this direction, it will not fail. What is the reason? Material has higher resistance. Okay, so we need to figure out that what is the effect of all these forces in the plane stress formula. So a material, I'm thinking it will be a split due to those force. It just divide become two part along longitudinally. It can break in any direction, might be this direction, might be right over here. Any direction it can break up. But I am just thinking now that if it is break down along this direction, become two part, then how much force will work in this free body? That means I slice it, then I take the upper half. This is my upper half. And upper half, how much force I have? I have sigma y, I have sigma x, then I have tau xy, tau xy. So I can say this one sigma x, this one sigma y, both are tau xy. Now see, this body is not balanced. Obviously, right over here, some force is working. It might be any direction. Say I'm just saying this force working. There is a shear force working along this direction. Along this direction, there is sigma working, and this one I'm saying tau. Now, how much will be force work in the lower portion? So if I draw the lower portion, then I will have this sigma x along this direction, sigma y along this direction. Now see there is a tau xy, right? Tau xy along this direction, tau xy along this direction. So obviously there has to be some force. So this tau right over here working upward. So this tau will be downward, and this one working along this direction. So this has to work along this direction. So I say this is sigma, this is tau. Then what happened? You close together. Then this sigma, sigma will be out, tau, tau will be out. That means you're getting the actual figure. Now, this sigma x, tau xy, and sigma y, right over here, this will be sigma x, downward direction, this will be sigma y, this will be tau xy. So how did you see? Sigma x, sigma y, tau xy is the external load. I applied it. But what about this sigma and tau? This sigma and tau, you cannot see from outside because these are the internal load. Now, the resultant of sigma and tau, or this sigma and tau, is become higher than the resistance of the material. Then what will happen? It become break. It fail or become two part. And if this sigma and this tau is less than the resistance of the material, then the material will not. One second, please. Hello, Saib. Sorry. So what I'm saying that if we know this sigma and tau, say you have a pressure vessel, this kind of pressure vessel, At the top surface, you take a rectangular chunk. So along horizontal direction, there will be longitudinal stress. Say this is sigma x. Along this direction will be tangential stress. Say sigma y, this is sigma y. Now, if there is a torque during transportation, you can figure out the shear force. Their shear force work this direction, this direction, this direction, this direction. Now, how did you know that? What is the value of tau and this sigma? That means if you cut it right over here. If these two value you know, then you can figure out that your design is okay. Now, along this direction, sigma L, that means you can figure out sigma L equal to PD by 4T or PR by 2T. So this one I'm saying sigma X, this one sigma X. Similarly, tangential stress, you can say sigma Y, sigma Y. And tau xi value you can figure. What I'm saying, this sigma y is known to you. You can figure out this sigma x, you can figure out the tau xy. Only unknown is sigma and tau. If this sigma and tau you are able to calculate, then you can make a decision whether the design is right or wrong. So we need to have a formula. Mathematically, we need to have formula for this sigma and this tau. So let's see how we can figure out this value of sigma and tau. Right over here, I cut it along this direction and I make the two part. This is upper part, this is bottom part. And in the bottom direction, I think this is the tau working downward, right over here tau working along this direction, sigma. And this tau, this one over here, you can put upward, no problem. If you put upward over here, then over here will be downward. So what we did, we cut it the body right over here, then this one keeps same. And over here, we think tau is upward, sigma is tension. And this angle right over is phi. So similarly, in the top upper portion will be, this is tau, this is sigma, this is angle phi. Now, if sigma x and tau xy is known, how I can figure out this tau and sigma? Anyone? You will get some plus point. Let me know. Anyone could tell me how we can figure out?
Sir, can you repeat the question?
Right over here, you see the rectangle, right? So this sigma y is, known value. Tau xy we know. Sigma x we know. Say angle phi we know. How will figure out the value of this sigma and this tau? You can figure out
So by tan,
by
since tan data.
by tan.
Yes, sir.
By tan, how will figure out?
Sir,
The force. This has certain thickness, right? So what I'm saying, this is a kind of plate like that. So how you will apply tan to find that? With tan, you cannot do it. Okay, this is a, say, rectangular. Actually, its shape kind of this one. Okay, this one. We just draw the front view. So your tau xy, working this surface along this direction. Okay, along this direction in the bottom. Sigma working sigma y downward. Right over sigma x working along this direction, tau xy working along this direction. Then this tau is working along this surface. And this here, sigma working perpendicular this surface. Okay. Now, my question that this sigma x we know, tau xy we know, how I can figure out this tau and sigma? Anyone? What is your ID?
Sir, 135.
135. Anyone could tell me how we can figure out?
So by taking component,
Which component? How?
so as phi is given, so angle is given, then
Yeah, angle is given.
So by
then
using
sin
force
theta,
triangle,
cos theta
By using
component,
component. What component?
x component and y component.
X component and Y component. Good. That means summation of force will be 0, has to be 0 along x-axis. Okay, before who talk with me? 135, right? ID?
Yes, sir.
135. And okay, now go ahead. What I'm saying, you take summation of force along x-axis and y-axis equal to 0. You get two equations. How many unknown is about here? Two unknown, one tau, one sigma. To solve two unknown, you need two equations. So if you take summation of force along x-axis equal to 0, summation of force along y-axis equal to 0. And this force, you need to figure out the component, right? Like tau, if I tau working along this direction, this is phi. What does it mean? This is phi. So you can make two components, x and y component. Similarly, if I make a vertical line over here, then this angle phi, this is phi. Then this is also phi. Then you can make component of sigma, vertical axis and horizontal axis. Okay. So we have to take summation of x and summation of force along x and y direction equal to 0. Then we get two equation. If we solve this two equation, we'll get value of tau and the sigma. Okay, roll 135. Then who was talking with me?
So 131.
131. Okay, good. Now, let's see how we can do it. Right over here, I just put some angle. We know this is the phi. So this will be phi and this will be phi. Okay. So how we can, you see right over here, how we figure out. This is phi, right? This is phi. Then this angle will be phi, right? And what is this angle? 90. So this will be 90 minus phi. Again, these two, right over here, this is 90. So 90 minus 90 minus phi. So finally equal to, you get 90 minus, you get phi. So this angle is phi. Before I told this, I was wrong. This angle is phi. So you can easily figure out. Now we will take summation of force along x and y direction. Okay. Now, so how we can derive the plane stress formula? We are considering an element, that element size along x-axis is dx, y-axis dy, z-axis dz, cut by an oblique plane. That means you cut it diagonally, and this angle made angle phi. Okay, now what is dx dy? If I make this body, it will be 3D shape, it will be like that. Okay, it will be like that. So this length from here to here is dx, from here to here dy, and from to here to here this distance dz. Then this distance also dz. This is also dz, this is also dz. That means thickness is dz, right? Now, say I like to make force balance in right side triangle. I cut it diagonally, and you see this one, this force, this sigma is same, only magnitude opposite. This tau is same. So you can work with any triangle. So if I took this triangle, then I will apply summation of force along x and y direction. Okay, now, so this length from here to here will be dx. Length from here to here will be dy. And this length I don't know. So we are just thinking this length is ds. Now, you see how we'll figure out summation of force, because it's given stress, not the force. So we need to apply a little bit tricks, that stress equal to F by area. So F equal to sigma into area. Now, how will get the area? Say we're considering left side, I will get the area. If we draw a 3D view little bit, then you can figure out. Say this actually, let me erase this one. So I am thinking this is actually a rectangular plate. So from here, okay. Now, say I like to figure out summation of force along x-axis. First, you consider right over here. Tau xy working downward. This is not x direction, right? Only have sigma x. So sigma is working negative x-axis, so sigma x into, you need to multiply by the area. So what will be our area of this face? From distance from here to here is dy, and from here to here you can say dz, thickness, right? So sigma x into dy into dz. This is the force working negative x-axis. At the bottom, sigma y working downward. We are not taking. We have to take force working and x-axis. So tau working negative x-axis. So minus tau xy. Now, what is this area? This area. Distance from here to here is dx. So dx into thickness dz. This is the area. Okay. Similarly, how we can figure out this tau working along this direction. So this is phi, this is phi. So along x-axis, this is tau, right? So along y-axis working tau cos theta. And along this direction working tau sine theta. So this tau sine theta, if you multiply this area, you'll get the force. That means force is coming tau sine theta into area. What is area? This distance. We consider ds. So ds into width. What is the width? dz. So this value will be negative. Now this sigma, this angle is the phi. So force will be sigma cos phi. Force over here. And vertical component will be sigma sine phi. Okay. And this is stress. On which area will use? Area will be ds into this thickness. Thickness, that means dz. Similarly, we can apply summation of force along y direction. Okay. So you don't have to be scared. I'm just giving you the introduction of the solution. That then after we solve it, we will get this equation. Sigma equal to this one and tau value equal to this one. So I just give you the formula. Now, you might think the sir just giving the formula and just tell about little bit that how it is work. Okay. So within 5 minutes, I'll finish the class. Okay. So just take a passion. Going the new share. Let's work with MathCAD file. Okay. Did you see the screen? Hello?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
In college and also in first year, you learn a lot of math and you might think, what was the application of your trigonometry? You see, right now, we will apply your math knowledge and also your knowledge from engineering mechanics in the solid mechanics. So this is our free body diagram of the half of the portion, bottom half portion. What is our target? We need to figure out equation of sigma, equation of the tau. Now, you see some equation right over here that we needed to simplify the formula. That's why I put it. But in the exam, you don't have to put. I put it over, what is the cos phi? Cos phi will be base by hypotenuse. So this is dy by dz. Similarly, sine phi, then I just put this formula. 1 plus cos 2 theta equal to cos square theta. 1 minus cos theta equal to how much? That's I put over here. And I thinking thickness of the plane stress element is dz. And this is the formula, fundamental formula. So we can figure out F equal to sigma into A. Now, right over in this body, we'll apply formula. Summation of force along x direction is 0. And you look how many force is working along x direction. Number 1, this is working along negative x direction, tau xy. Sigma x working along negative x direction. Now, what about this T force? You just make component of sigma. So you see sigma one component working vertical direction and this component working sigma cos phi working positive x-axis. So 1, 2, then we have one more, 3 force. Then this tau working along this direction. So this tau you can component into along x-axis and also along y-axis. So our concern is now with x-axis. So how many force? 1, 2, 3, 4. So let's take right over here. In the bottom, summation of force. So minus, first take this one, minus sigma x, because negative x-axis. This is sigma x. What will be the area? This length is dy, thickness dz. So dy into dz. Then this tau xy, negative x-axis, minus, this is stress, What is the area? dx into dz. So this is the area. Now this one, horizontal component will be sigma cos phi. This is horizontal component. What will be the area? ds into dz. This is the area. This component of the tau working negative x-axis, so minus sign. This will be tau sine phi and upward sine cos phi, tau cos phi. So we take sine phi into tau. What is this area? ds into dz, right over here. Okay. Now we just simplify it. From all the dz will be out. So now this dy, we can substitute dy equal to right over here, ds into cos phi. Dx equal to ds into sine phi. That you put over here. Then you see ds is gone. You have only this one, sigma cos phi tau sine phi equal to this formula. This is equation 1. You see right side is known value. So now we need to make summation of force along y direction. Along y direction, how many force we have? We have sigma y. We have tau xy, this component and component of tau. So after reporting, we get sigma y minus right over here. You look right over here. dx into dz is the area. dx into dz. This tau xy minus this tau xy. We are considering along y-axis, not this one. So this tau xy minus dy into dz. Then this sigma, we are taking vertical component. So sigma sine phi. This sigma sine phi ds into dz. Then this one, vertical component tau cos phi. So tau cos phi area ds into dz. Then this ds equal to ds into sine phi, dy equal to ds into cos phi. Then see all ds will be out. Finally, you got this equation. So two equation, two unknown. You look carefully this equation. This tau sigma cos phi, tau sine phi. Sigma sine phi plus tau cos phi. If you add directly, you are not no benefit. You cannot solve it. But equation 1, you multiply by cos phi, then what you get over here? Tau sine phi cos phi. And equation 2, you multiply by sine phi, then you'll get tau sine phi cos phi. Then you add these two equations. Then you see this term, and this term will be cancelled out. So right over here, we're saying equation 1 multiply by cos phi, equation 2 multiply by sine phi, then add together. Then we get this one. Left side cos square phi plus sine square phi, over here sigma x cos square phi tau xy sine phi cos phi, sigma y sine square phi tau xy cos phi sine phi. Now you can just simplify. You take sigma common, then you get cos square phi sine square phi equal to 1. So left hand side sigma cos square phi. Right over here is the formula. Cos square phi equal to this term divided by 2. Sine square phi equal to this term divided by 2. So we put it over here, these two right over here. And this tau xy is same, so plus 2. Now this one equal to sine 2 phi. So tau xy sine 2 phi. And right over here, you just multiply with the 1.5. Then you'll get sigma x plus sigma y divided by 2. And you'll get sigma x minus sigma y divided by 2 we keep the bracket cos 2 phi common. Then you'll get this equation. So this is the equation for sigma. Now, what will be equation for tau? You just you need to take out sigma. How you can do it? You see, this one you multiply by cos phi. This one multiply by sin phi. Then you subtract from here to here. Then you'll see this term will be out. You'll get the only tau. So similarly, right over here, equation 2 multiplied by the cos phi minus equation 1 multiplied by sin phi. Then you just simplify. Left side you will get tau into cos square phi plus sin square phi equal to 1. And you get right side this one. Okay. And this value cos square phi minus sin square phi equal to cos 2 phi. That I put cos 2 phi. Just simplify, you'll get this one. You get equation of tau, you get equation of sigma. So what did you see over here? If you know the sigma y, tau xy, if you know the angle phi, you can figure out this sigma and this tau. Any question? Anyone? Any question? Hello? No question?